Hi everyone, welcome back to my channel. If you haven't yet watched the part 1, I would recommend you to watch the part 1 video, link is in the description. And if you already did, please like and comment on the part 1 of my exploratory data analysis project using advanced Python. I am excited to present part 2 where we continue to dive deeper into the real world data cleaning, transformation and visualization using Pandas, NumPy, Seaborn and Plotly. This continues our journey through module 2, numerical programming with Python, and is a must-watch for data science enthusiasts. If you find it helpful, do like, comment and share. Your feedback really helps me grow. Part 3 is on the way, so stay tuned. Let's get started.
Talking about the IMDb score, IMDb votes, TMDB popularity and IMDb ID, which is having blank. So we have filled blank into that place. For the others, I have filled with the mean and median of the same. For the TMDB score and character, we are going to do the same. For the characters, we have filled non-mentioned there, and for the TMDB score, we have filled the mean value there. For scores, we have filled the mean value, and for the popularity and votes, we have filled the median value. So, which value to be filled at what place will be determined by the type of column that it is. So the type of entries that it has, like for the votes and popularities, it has values in thousands. So we cannot fill the particular mean for those particular column, as that will create a very chaotic type of data. Though that can be done in the score columns, because they are having the score up till 10 only, so we can fill the mean of those particular kind of values for the same. Now learning if we have any other null value left in the columns of this particular data set, we can see that there is none. So talking about what we know about the dataset by now. So as we know that we had two CSV files, we had titles and credits. We are summarizing everything again, that we have combined both of the two, and we have identified that there have been content compositions. We can understand the split between movies and TV shows by dominant genres. We have the audience targets by examining the age certifications and genres. We have the performance indicators, which are IMDb and TMDB, scores and votes and popularities columns, which can help us to access the success of the titles. Also, we have temporal trends, which are going to give back the content strategy that has evolved, including shifts in the genres, focus on the audience preferences. People analytics is going to be taken up from the credits part of the dataset, which is going to help us track the actors or directors frequently which are contributing to the high performance contents. So the business insights and applications, what we have here is content strategy optimization, which is going to identify high performing genres or regions, spot underrepresented but high potential areas, personalization of the recommendations, using historical rating trends to improve algorithms that suggest content to users based on genre and viewer profile. Next is a talent acquisition retention, that is going to help us analyze that which actors or directors are continuously or constantly delivering the high rated content, and are going to help us informing the casting and contracting decisions. Another critical point that is going to be discussed will be for the customer segmentation, which is going to use the age certification and genres preferences to segment audience more precisely and guide targeted marketing campaigns. So, talking about the summary, what we have in the data set is that it is a rich source for evaluating the content performance, understanding viewer preferences, shaping business strategies in streaming industry. Insights derived from it are just not academic, they translate into actionable strategies for growth, retention and competitive positioning. So starting with the understanding of our variables, we can see that we have this number of columns that are available right now before cleaning. Then we have after cleaning, before the manipulation, we have the describe function, which is going to let us understand the descriptive data of the numerical based columns. So the descriptive column is going to give us all the descriptive data about the stats about this all the numerical based columns from this particular data set. So talking about the variables description, which is like bifurcated into the data sets that were previously there, which is titles and credits. So as you can see, for the titles data set, we have that content metadata, which is going to give us all the column names, their particular data types, and the description. Also, there have been the credits, which is dataset 2, having the cast and crew info, giving the person ID, name, character, and role, having the data type and descriptions as well. So, since the two original datasets were merged into one, further the operations will be carried out on the merged dataset itself. Talking about the unique values for each variable. So we have run all the particular set of codes at once, and we got to get all the values for each of the following commands. So starting with the data wrangling part. So here what we are going to do is we are going to discuss step by step what the transformations were done for the wrangling. Starting with the first point, that is transforming the release year column. Here we have the column with only year values, which is in the data type int. So what we are going to do is keeping the year column as it is, and we are going to create a new column besides that, and that will be having the data type in the date time format, which is as given here. The new column will be helping us to make the visualizations more efficient, and it will help us to work as per requirement, manipulate as per the requirement, and we can use the data type column while fetching the trends, and use the int type column to fetch the normal counts of or the other descriptive data. Running this particular set of code, we have actually what we have done here is we have taken the year date. We have created a new year date column, which is going to give us the date time, year for the from the release year, and rest will be 1 and 1, which will be giving us the result as you can see. One more thing that we have done is we have created the column, but we haven't arranged the index for the same. So what we have done right now is columns is equal to list of Amazon Prime columns, and we are going to fetch out the release year index, and using this particular columns variable, and from that we are going to insert the release year index plus 1, that is will be updated to the next index of the release year column, and the column will be having there will be year date by the name year date. So as you can see, when we use the head command or the head function, we can see that year date is one of the columns which is having year, month and date for the same. Since we did not have the date and the month part of the release year, so we can by default use the 1st January for the same for all the instances. Moving on with the info of this dataset, we can see that we have the right data type for each of the columns, and we have no null values left. We have no duplicated values there. Starting with the operations. Now creating new credited column. Why is it necessary? We can see that we have, if I show you the particular, if I show you this particular table which I have fetched from the clean dataset, we can see that we have a character column which is going to give us the characters that are played by the actors in the particular film, movies or shows content. So you can see this uncredited is written here for some of the entries, and we can say that since the characters were bifurcated based on if they are credited or uncredited for the particular role that they played. We are not having the details, and we can basically use a new column that will help us fetch the credited and uncredited value in the form of boolean. We haven't just taken the boolean part. We have used yes and no for the actors who are having credited or uncredited character, but we are also having any value which will be there for each of the uh, roles, if the particular roles will be for the directors. So directors do not play any role, so they won't be having any credited or uncredited value for the same. So we have used any for them. And as you can see, since they were not having any character also present for them, so we have used directors directly written in the place of the name of the characters for the role director. Moving on to the next part. As you can see, we have created a credited column, and we are taking not the character value which is having uncredited, and then we can place yes for the same. We can have the case false and any false, and rest is giving us the column which is going to give us the credited column just beside the character column. And now we can see that we have characters, and we are going to give if they are we give the value if they have been credited, that will show a true or yes. We have converted this true and false or boolean part into yes or no, because we are also having some any values which were present for the director's role. So moving on, the same thing I think we have done here. We have created the columns, we have created it into the form of a list. Then we have taken an index, and we have placed the credited column just besides the character column or next to the character column. And then we have printed the columns. You can see that we have, after the character column, we have credited column placed here. Then we have another part where we are going to check for the info first, and then we are going to convert the true and false or boolean value into the yes, no and any part. So you can see here we have used the NumPy for this particular thing, and we have taken the condition that if the role will be having the uppercase value of director, that will be giving a value NA. Otherwise we can have the default values to be yes and no for respective to the particular characters, having true and false corresponding to them. We can see that the credited unique values are now yes, no and any as required, and we can take the head of the particular data set using the head function, and can find that we have any, no and yes values as per our requirement. We have any value for the director part, and yes or no based on the actor and their credited and uncredited detailings. So starting with the next part. Third, we are going to create a boolean type multiple genre category based column for genre column, which is going to have the particular values in the form of lists. As you can see here, we have unique values fetched out using the unique function. For the genre column, we can see that the values present in this particular column are in the form of lists. Either they are 1 or 2 element based list, or 3 elements based list, or multiple element based list. We are also having a sum of 6 values. You can see in one of the elements of the list, which is not the right structure for fetching the insights for this data set. So what we are going to do here is we are going to perform this operation by actually creating the whole genre, unique genres as set, and this set will be having all the values which will be taken out of the as.literal taking items, and this will basically fetch out all the individual values from all the lists, from all the elements of that particular column, and will be having they'll be separated, and each will be considered as one genre, instead of how the particular column was having the elements to be in the form of lists of multiple genres. So here what we have done is we are going to take up the length. So this many amount of columns are basically going to be created later. So we already have 20 columns and we are going to create 19 other columns. So doing the same, what we are going to do is we are going to distribute the genres in the form of columns. So we'll have basically, if we have 19 genres here, so we'll start with action, animation, comedy, crime, documentation, drama, and so on. We'll be having each of them as one particular column, and we'll be having the boolean values which will be giving the answer as yes or no, the entries as yes or no for each of the particular film. So if a particular film is having multiple genres available for that particular movie content, so it'll have a yes for each of the particular genre based column, the name of the genre used as a particular column, and we'll have a yes there, and the others will be neglected by having a no. And this way we can fetch one particular genre for each of the title by not mixing up each of the other genres which are not supposed to be fetched for that particular movie. And we have created each genre into column, and as you can see here we have now 40 columns available for us. 40 columns will be available to us with 1 to 4 179 non-duplicated rows or entries available for each column.